Here we go, 3 o'clock session, and we have our next speaker who comes to us by way of the Research Triangle in North Carolina, Tim Tyler, Docker Captain and Principal Engineer at MetLife. Tim has a great story. Actually, he's got a lot of stories to tell about Docker, but as you can see, he's dressed appropriately. It is Avengers t-shirt. No spoiler alert is needed here. He's promised not to reveal any critical storylines in the movie. I haven't seen it yet. So let's welcome Tim.
Thank you. My name is Tim Tyler, and the title of my talk is Operating Docker Platforms Like an Avenger. I am a Docker captain and a principal engineer with MetLife, and you can find my contact details on this slide and at the slide at the end. So what is this talk about, and why do you care? And let me thank you all for coming. It's always such a pleasure to have a good turnout when you put a talk together. So this is an overview of operating Docker Enterprise Edition at a very high level. And I don't have a lot of time. I have like 35 minutes or so. So I'm going to really skim over a lot of things, but hopefully you'll find some value in them. About 2 years ago, I came out to DockerCon. I think it was in Austin when I spoke about MetLife's journey to productizing a Docker application in late 2016. We went from zero to a fully blown production application between June and December of 2016. And we had a really good story to tell about that. But in that 6 months, we didn't learn everything. And since then, we've learned a whole lot of best practices and lessons learned and things that allow us to wrap a bunch of sanity around the Docker platforms that we're supporting worldwide now. So I go over lessons learned. I go over some pain points that we encountered and still encounter today and how we deal with those. And I go over some usable patterns that hopefully are things you can learn from and take away. I'll tell you right up front, this isn't a super technical talk. A lot of the stuff I'll talk about probably sounds like common sense, but it's things that weren't necessarily common sense to us right at the start. And these are things that we've picked up and that I wanted to share. I do have some imagery, some pop culture imagery. It's not just Avengers embedded into the presentation. I actually leaned towards 1980s references, generally speaking, just to keep it a little campier. But I promise it's not going to be too campy. I also swear, I don't know about you, it's been a really stressful weekend for me with Game of Thrones and Endgame. I've seen them both. I won't give away anything. So Docker is totally awesome, because one of the key points about Docker is that it's so easy to use. It's so easy for developers to deploy applications into a Docker environment and to do what we did at MetLife, go from zero to production in a matter of months for our first microservices-based application. But because it's so easy, with great power comes great responsibility as well. And you have to make sure that you do not overlook the operational details of the Docker environment. Otherwise, it can become very uncontrolled. It can become very difficult to audit. It can become very difficult to manage over time. So when I first talked about our journey, I talked about our operational handoff from our platform engineering team to our operations team. And I called it when an unstoppable force meets an immovable object. And I didn't have any Avengers imagery in there at the time. If I were to go back in time, I wanted to put in that one from Thor Ragnarok, where Thor and the Hulk were flying at each other in the arena. And I thought about putting that here, but really that's not the story that I want to tell, because we're not an unstoppable force meeting an immovable object anymore. Now our platform teams and our operations teams work very closely together to make sure that we're operationalizing Docker and that we're able to manage the environment and the ecosystem that we have running at MetLife in a coherent way. And we run clusters all over the world. We have clusters in the United States. We have clusters in the Middle East. We have clusters in EMEA and LATAM. So we've got a lot of clusters to manage, along with a lot of microservices and legacy applications running in those clusters as well that we need to wrap our heads around. So one of the key things that I tell my colleagues, and that I think my colleagues would also state, is keep it simple. It doesn't have to be hard to properly manage a Docker environment. We manage with simple automation, usually with Ansible or Chef or orchestration tools like that. Even bash scripts we'll resort to help us manage our Docker environment, especially in terms of auditing the environment and slicing and dicing the reports that we pull out of Docker, which I'll talk about a little bit later. We try to keep our handoffs as simple as possible. And these are application handoffs or image handoffs or container promotions from dev to int to QA to prod. We wrap a lot of compliance around that, but we try to keep that in line with existing corporate policy for compliance needs without inventing new wheels for these handoffs. All of our standards are well documented, and I'm going to dive into that just a little bit deeper later on. Everything is auditable. Because we're an insurance company, we're required to be highly compliant to different kinds of regulations all around the world, so we have to maintain an exceptionally auditable system. But the overall guiding principle is keep it simple. At the intersection of dev and operations and engineering, we want the environment to be managed as simply as possible. So some of the pain points that we found is Docker offers a ton of freedom. This is really cool, and you would think, why is that a pain point? Well, obviously it's a pain point because that freedom allows you to do all sorts of things that can violate policies or violate standards or violate just how you're deploying an application into the environment so that it's easily manageable by an operations team. We found that our developers, bless them, are not always aware of the change that's going on in the Docker environment. So we'll get new releases of Docker, we'll get new features, and they won't necessarily read up on the latest changes, and that can come back to bite them in the end. And I'll just point out that we have thousands of developers, so it's a challenge on both sides to expect our developers to be aware of what's changing in the Docker environment, as well as making them proactively aware of what's changing. Docker can be extremely sensitive to operating system impacts. And my water's over there. Pardon me. What we found, thank you. What we found is, I'm sure everyone else has found this as well, is that changes to the underlying operating system can and do impact the stability of Docker. We found in particular running scanning agents or underlying security audit tools on the base operating systems can write log files in places that Docker doesn't like them, and if these things change unexpectedly, it can destabilize the Docker environment. So we're highly sensitive to what's going on in the underlying operating system today in our Docker clusters. And anytime we encounter a failure where we haven't encountered that failure before, we'll build a test for it, so that we can proactively react to it in the future. One thing we found is it's a Docker problem unless proven otherwise. I think this is a callback to when everything was a network problem. With your Docker clusters, it's always a Docker problem. That's not always true. In fact, 80% of the time it's not true. We find that we very rarely actually have things that we trace back to actual Docker issues. But because people are running in a new environment on a new platform, if it looks and smells like a Docker problem, it must be one, so we have to treat it like that until we resolve what the underlying problem is. So just briefly, I'm going to go through a couple of cluster setup scenarios that people have found successful. This is a single cluster setup that many people will recommend if you're setting up your first clusters. You'll note in particular that there are 5 manager nodes, and that's true in this case because it is a single cluster setup. In this scenario, we can lose 2 manager nodes and still have a fully functioning cluster, which is very convenient from a reliability point of view. We run 3 DTR nodes in a cluster, in a set on the cluster, and then we have what we call utility nodes. This is a concept that not everybody might be familiar with. We set aside a segregated set of utility nodes in our Docker environment to run stateful applications. So for instance, if we're running something like Prometheus, which needs to write state to the file system, or MongoDB, or Postgres, or something like that, these workloads will be passed off to the utility nodes where they'll maintain storage drivers that are appropriate for them. And then we have just the regular worker nodes, which are our stateless services. So this is a very highly resilient, fault-tolerant, but not very geo-tolerant cluster setup. I think a better cluster setup, if you have the resources, if you're geographically distributed in particular, is what we call a prod and a DR setup, or a multi-cluster setup. It doesn't have to be prod and DR, but that's what we call it. Here we've scaled back to 3 manager nodes in each cluster, just from a cost savings point of view. And we keep the rest of the geometry of the cluster pretty much identical. We run DTR nodes in each cluster that mirror each other. We run a set of utility nodes in each cluster, and we run our stateless nodes in each cluster. The cluster itself is active-active, so both sides, prod and DR, are hot all the time. The applications themselves might be active-active, or they might be active-passive, depending on the needs of the actual client. So this is highly resilient, very fault-tolerant, and also a very geo-tolerant setup. When we set up a cluster like this, we'll set up, for Ingress traffic, we'll set up some global load balancing, where we'll have a front-end load balancer intaking traffic from the internet, and we'll route that traffic through either a web gateway or an API gateway, depending on whether it's HTTP or TCP traffic, and then route that down to a back-end load balancer, which then hands off to whichever cluster is appropriate for that application on ports 8080 or 8443 respectively. And we're running interlock on the Docker Enterprise cluster, and we've got interlock configured to sort the traffic out at that point. So this is really a high-level view of how we're managing an active-active cluster like this. What's important to note from an operational point of view is I get a lot of control over how I manage my application with the back-end load balancer that's in place there. We can make a lot of changes in these clusters with the application, leveraging the features that Docker gives us, but also allowing us to reroute traffic without changing anything from the above the back-end load balancer, which is really nice. You'll also see on the prod data center some things at the top. These are usually things that are not part of the Docker cluster, like deployment agents or certification authorities or single sign-on or LDAP or security scanning servers and things like that. This is where 80% of the problems actually occur when it's a Docker problem. What we find is it's these connections to the external services that are causing us problems with firewall issues or routing issues or things like that. So that's the good news. But those are things you always have to think about, because you can't get away from these external services that are also allowing you to manage your environment. Process and procedure is critical when you're going to manage a Docker environment, and you have to ensure that you have a solid governance model in place. You have to ensure that you have oversight of the applications that are onboarding into your Docker environment, and that it's not going to be something that just becomes the wild, wild west, and that you establish policies that promote a well-managed environment. And I'm going to go over some of these things in the next few slides. One of the first things that we do when we engage with a new development team is put them through a developer onboarding process. And this has been critical for the success of our onboarding applications. Step one, every single developer or development team that will be onboarding into Docker has to go through Docker training. They have to speak the Docker language, at least at some level. They have to be able to have conversations with us about what's going on with their microservices or with their legacy apps, and how they're being containerized, and what the best practices are for containerizing them, how to use multi-stage builds, for instance, and what we mean when we talk about running multiple microservices at a time, because it's not always intuitive to the developers. We give training classes based on PWD today globally. So we've got people interacting with Docker environments that aren't directly on-premise, so that they can come up to speed with Docker. Two is their code must be working on their laptop before we will allow them into the production platforms, or even in our development platforms. They have to demonstrate that the code works on their laptop, and then they have to take it a step further and demonstrate that their code works in a sandbox. Once that's complete, our developers can then turn to our team that runs our CI/CD processes and complete the onboarding through them. So we get their continuous integration and deployment pipelines set up in advance before we ever deploy them into a development environment. Once they're deployed into a development environment, they then go through just standard promotion procedures to go from development to int to QA and to prod. So we think that training is absolutely critical for everyone. It's not just the developers. The engineering teams need to be trained, particularly the platform teams, and our IT risk teams need to be trained to understand Docker and what the impacts to the environment and exposure to security risks are, and our operations teams obviously need training. Originally, we got a lot of resistance to this, but we pulled through. We set up 2 or 3 weeks of hands-on training for everyone. This was a couple of years ago. Now we've kind of streamlined that into different training offerings that people can take and given them access to tools like Udemy and Pluralsight so that they can complete training there as well. We leverage PWD, like I said, to take advantage of particularly remote training if we're doing training for folks in APAC. But what we found is people are really busy and they're not always going to show up to training. So here's my slide with everybody not showing up to training. This is literally a class that we were giving, and I was sitting in the front, and that's my colleague, Ben Stein, that was giving a talk on the infrastructure that we were putting under our Docker clusters, and I couldn't believe there was nobody in the room, and I just had to get a shot of that. And that's my Bueller moment. For this particular training. There actually were a couple dozen people on the phone on a WebEx, so it wasn't quite as bad as it looks, but I thought that was a pretty impactful image of people not coming to training. Image scanning is critical. Our source code goes through its traditional scanning algorithms just like it normally would, and then we build our images and push them through scanning via DTR. One thing that we've found is that because our churn in lower environments is so high, we've had to move quite a bit of our image scanning up to our QA and prod environments. It's not that we don't scan in development environments, we just scan major releases in development environments, not incremental releases. And then we scan everything that's moving into QA and prod. And this is really just a result of the load that the lower environments were putting on the Docker clusters as a result of the high churn rate through the code that we were building. And we tend to build fairly large images as well. The picture, if anybody remembers, is from Total Recall when Arnold Schwarzenegger walked behind the screen. So we found that clean images are unicorns. I know of a few that I can think of off the top of my head, like the last time I scanned the Prometheus base image, it was perfectly clean. But in general, clean images are unicorns, and you'll find a lot of vulns. We export our scan results to a third-party scanning scorecard, and I highly recommend this, particularly if you're in a regulated industry, to keep track of your scan results over time so that you can score them and you can look at when new vulnerabilities have been encountered in old images and things like that. So that's really important. Fortunately, our tool that gives us that scorecard intakes JSON, and DTR conveniently outputs JSON, so there's a natural marriage there with them. There are other tools, though, that take CSV input, so sometimes you have to massage the input to get it from DTR into whatever you're using to manage those vulnerabilities. Operating system currency is key, and I mentioned this earlier. Compliance scanning agents can cause a lot of problems in the operating system with our Docker platform. Change can be very unpredictable, and we try to test for every single change. What normally happens is we've got a suite of tests, and these are super simple tests. There's nothing fancy about them. Most of them are bash scripts that we use to go and probe the operating systems for unexpected change, and we'll catch change quite a bit that we can then go proactively address, but sometimes something comes along that we didn't expect. Somebody updated a scanning agent or a security agent on the host, and we'll see a destabilization in Docker. And once we catch those, we build a test for that too. One example was a very specific combination of a scanning agent that we used with a specific Linux kernel version was panicking our hosts. And it took a while to sort that out. And it was not the expected combination of things that we thought we would find, but that's what we found. So then we built a set of tests around that to test for changes to that specific scanning agent and any unexpected uprevs to the kernel version that could be happening just because of a result of business as usual operations. One thing we did that we had a lot of success with, and I spoke about this when I gave the first iteration of this talk, is a concept that we called war games. We were in the process in our engineering teams, our platform engineering teams, of shifting left to managing everything as infrastructure as code. And with that came the ability to test all of our infrastructure as code as well. And then we used those IAC concepts to build up our Docker platform. And when we handed that off to operations, we built a set of war games, or a set of tests that we turned into war games that we played with our operations teams. And this was a lot of fun, and it really helped our operators come up to speed on the platform. So you can think of it as like a manual chaos monkey. But what we did was we set aside a couple of weeks, and we would just randomly inject failure into the Docker clusters that we were playing the war games on with our operating team counterparts, and measure their response and return to service as a result of those injected failures. And over a 2-week period, we were able to very clearly measure how quickly they could improve their response time from the beginning of the 2 or 3 week period to the end. So what took 3 hours to recover at the beginning had collapsed to something like 15 minutes by the end. And the failures were fairly straightforward. It was randomly kill an application, a utility application like Prometheus or something like that, or randomly kill a set of microservices that are in a 3-piece set, for instance, or taking it a step further, kill off a worker node, or kill a whole entire fault domain on the cloud provider that we were in at the time. Or in one case, at the end, we killed the entire cluster just to make sure that our DR strategy worked properly. And we were able to track the improvements to these responses from our ops team very clearly, and it was a very compelling story that we were able to tell as a result of that. So it was a lot of fun. Out of that came tests for everything again, and we just did that over and over again with them. And this is actually, I wanted to put this up. Mark Church at Docker made this because he thought this was such a cool story last year at on a panel that I was on, and he never actually showed the image. So that's our Iron Man War Games image, which finally gets a little bit of airtime. One of the things that I stress from an operating point of view is labeling absolutely everything. Docker can be exhaustively labeled, and your ability to go back and audit the environment and the applications that are running in it are exceptionally enhanced if you've labeled everything. So we build in labels for project and finance codes. We build in labels for chargeback codes, and if you have a chargeback model, that's critical. We build in labels for geocodes and external provenance, which is essentially where did this image come from. We rely on base images from our internal Docker trusted registry that we have taken in from external sources, but then we have modified them to meet our specific needs. So those images will get relabeled so that they show the provenance regarding where they came from. So if they came from Docker Hub, the provenance label would say this came from Docker Hub, and it would give the path to the image and the specific label that image was pulled from. But we take ownership of those images once we bring them inside the company, and never build an actual application image from an image that had a from statement that would point back to Docker Hub. It would always point to our internal DTR. We manage our internal maintainers with our labels and metadata. We have call-outs to who the support group is. We have call-outs to where the operational guides for that application or services. We have either a call-out to where the test script location is, or in some cases, we'll embed the entire test script as the value of the label. We run an expected count so that our operators always know by inspection how many instances of a specific microservice should be up and running. We have a max count counter as well. We label the services with what failure domains they should be running in, so that we can spread our loads across failure domains in our cloud provider, and we note the environment as well, whether it's dev, prod, QA. This is a subset of the most important labels that we track. It's not all of them. We always follow a standard labeling convention where it's com.company, where company is our company name, MetLife. So it would be com.metlife.docker.something.helpful, where something.helpful is what is that label all about. We've taken in images from third-party providers where they've been really lazy with their labels, and they'll just say build number, or ENV will be the key for the label, and that drives me crazy because I can't tell where that label came from. I don't know who put it there. And in our case, because we're enforcing these standards, we know that it didn't come from us at the very least. How do we enforce those standards? We lint everything. We lint our Docker files, and we lint our compose files. So that's part of our standards management process. You can find a really nice Dockerfile linter on GitHub. I have the URL there. Our Dockerfile linting is fairly straightforward. You could build a bash script to do this really easily too. You could probably do it with Ansible. But it's a simple and extensible check for Docker files. We have just a very small set of simple rules for Docker files where the from statement must match a DTR server from our company. So it must be dtr.mycompany.com, in our case, dtr.metlife.com. The from statement must not contain latest as a tag, as a label. It must match a : tag or label, so it has to have something there. It can't be nothing. The user command must be present so that we're not running rooted containers, and a health check must exist. Those are the basic checks that we do for a Docker file. So those are super easy and pretty straightforward. A little more complicated is our compose and stack files, because those are just a little bit tougher to parse up and manage from a linting point of view. I am not aware of an open source linter for compose or stack files that is rule-based. I haven't looked very recently, but when I was searching for one, I wasn't able to find one, so we created one internally. So our rules for linting our compose and stack files are a little bit more extensive, and this is really kind of where the rubber meets the road in terms of managing what's going into the environment and how we report on the things that are in that environment. So the easy check must be valid YAML. Today, the version must be defined and must be equal to 3.3. There have been times where we've had a range of 3 dots in there that we're actively supporting. At least one service must be defined. And that check is there because we've had compose files where no one defined a service before, or at least tried to deploy something where no service was defined. The user command must be present, and then we have per service checks. The image is defined and properly sourced. There's label validation with required labels and syntax. So we've got a regular expression parser that'll go in and look at the specific required labels, some of which I reviewed before, and ensure that they're not only there, but that the value matches what we think it should be matching. You can still have failures there because you can't catch everything, but we can at least put a set of sanity checks in for label management there. We insist that a restart policy is defined. It can be whatever restart policy the application team wants, but it has to be there. We insist that the verify mode is defined. We verify that the replicas are defined and greater than 0. We verify that ports are properly defined. And every single one of these tests is a result of a case where one of these things hasn't been defined before. We verify that both the target port and the publish ports are defined. We validate that our external networks are defined. And the name cannot be blank, and the name conforms to a standard naming convention for the company. And then we validate the application type. If it's a layer 7 service, at least one L7 service must be defined. And if it's a port service, at least one port service must be defined. So this is whether or not it's going through a web, an app gateway or a API gateway, for instance. Or if both, we validate for both. So this is one of the key principles that we enforce hysterically is linting these files before they see the light of QA in particular. And then once they've seen QA, by definition, that's what we see in production. So we have to audit and ensure that we're in compliance with all sorts of auditing standards at a regulated company like MetLife. Every company should be able to audit their Docker environment. And once you've got all of these other things in place, once you've hysterically managed how you're handling your metadata in your Docker environment and what you're doing to ensure that it's there and correct, and verifying that people are properly applying the metadata and the properties of their applications and the compose files, you can very easily go back and build reports of these environments automatically that you can then manage in external systems so that you can see the change and churn in your environment over time, and you can report that change and churn back to any auditing authorities that are required, or back to the development teams, or back to management to demonstrate how that Docker ecosystem that you've built is existing over time around the world if you've got multiple clusters all over the place. All of our image scanning and output analysis goes to a third-party system. Today, we export that through Docker inspect commands. I'll show a couple of them in a moment. And then we transform them into CSV files, because that's what our third-party intake tool accepts. So this is a case where we have to do a little bit of management on the files themselves to get them to the appropriate place. We have our image promotion policies in place, which I highly recommend everybody using. In DTR is setting your dev, in QA, and prod promotion policies, and what are the required attributes to go through these different environments. And then centralized logs seems like something that you would just have, but that's not always the case, we found. Centralized logging isn't something that everybody has, which was a surprise to me, and it wasn't something that we had for a long time. But we make sure that aside from all of the enterprise logging that's happening, we're also extracting logs from an operational point of view so that we can churn through the container logs in a one-stop shop today. So that's pretty key. Otherwise, you get two types of undead. If you're a Game of Thrones fan, you've got the undead that attack you with swords and knives. If you're a Walking Dead fan, you've got the undead that shamble along and overwhelm you with sheer numbers. But that's what can happen to your Docker environment. If you don't police it, if you don't watch it, if you don't stay on top of it, you'll get undead applications and undead containers that are all over the place, eating you alive. So here's just a couple of random inspect commands that we use. This is variations on a theme. These are pulling out different attributes of the environment, and I left out the pipe, the logic that we do use to turn that into CSV, but it's pretty straightforward stuff. These are embedded in some bash scripts that we've written. We've got about 36 inspect commands like this that pull out different attributes of the system, and then we manage those in a third-party system on top of that. So I just randomly grabbed these two. I highly recommend a lab environment. This is outside of our non-production and production environments. We maintain a lab environment. It's a tenant sandbox with playground rules. And this goes back to one of the requirements for developer onboarding. Not only must our development teams demonstrate that their code runs in Docker on their laptops, they also must demonstrate that it runs in this sandbox. The sandbox is not a place where you put long-term stuff, and it can never be used as QA or production systems. It really can never even be used as a development system. It gets rebuilt periodically. We use it to validate new Docker features with the Docker Enterprise Edition 3.0, I think is the new branding, or the new version. We'll be installing that in our sandbox very soon, I think, so that we can start to kick the tires on some of the new Docker features. But our applications and customer tenants are welcome to use the sandbox as well. The sandbox gets rebuilt periodically. The period is normally weekly, but we can increase the frequency and rebuild as much as nightly. The nightly rebuilds are sanity checks for us that our automation can always rebuild a Docker cluster on demand. So if for any reason we lose one side of a cluster, a prod side or a DR side, we can rapidly rebuild that cluster with our automation because we're continually testing that automation with new Docker releases. And we also want to be able to rebuild that cluster on demand. So this seems like something everybody thinks about too, and maybe everybody does, but we don't. We're now we're hyper-focused on documentation. We feel that it's critical for our customers to be able to go to documentation to find the answers to their questions rather than to initiate a conversation with us. So we focus on documenting all of our architectures, all of our blueprints, all of our features, every kind of offering that we have for Docker, we hysterically document that and publish that to our internal community. We manage operations and return to service guides as well. These are separate from the publicly facing documentation. It's not that they're not public, it's just not what we would put on a wiki or a SharePoint or something like that. These are managed guides that have a life cycle. And we manage these life cycles over 6 and 12 months, 6 and 12 month periods. And every single ROS guide or return to operating service guide will have an owner and a consumer and a management contact that must revalidate that document every 6 months or every 12 months. And these are the guides that our operators use if there's an event that we don't have automation for, if there's something that occurs that is in particular not business as usual, or often even if it is business as usual, if we've got operators that are not focused on the Docker platform, they can refer back to these ROS guides and pull them out and have a script to return whatever failure has occurred to operating services. This is just a view of half of our internal documentation. It's about twice as long as this actually, but you can see we have a big FAQ section, a big how-to section. We're very clear on our standards and best practices. All of these links are live. All of them are reviewed periodically. We've got our application patterns and how we're managing our UCP clusters. So, anything that we can think of to put here, we do. I think in reality, this could probably be reorganized a little bit so it's not quite as noisy as it is. But just the fact that we have almost every question answered that any of our tenant customers could ask is huge, because then they don't have to open a dialogue with us. They don't have to sit down and spend an hour in a meeting or on a WebEx figuring out an answer to a question that we've already answered 3 or 4 times. So I'm almost done. And my last bit of advice is never use Spankle pods. They're bad. I think we're going to wait until the next iteration of Docker before we even think about using Spankle pods in our environment. So again, my name is Tim Tyler. Hopefully you got some nuggets out of this that are helpful. If nothing else, it's a story about how we've kind of evolved from beginning our Docker journey 2 years ago and building out a microservices-based production application very fast, but that was missing a lot of the governance and oversight that we have today, and the kinds of things that we've learned along the way and are able to share with other people now for managing a Docker environment. Not super technical, but I think there's hopefully some tidbits in there that are helpful for you folks too. I'm a Docker captain. I'm a principal engineer at MetLife. And thank you very much for attending my talk.